I might have different graph. Let's look at this graph. See, on an interval, so I'm giving you like a beginning and end to it. I might have a graph that looks like this. From this x value to that x value. Let's start with this one. Let's look at that point. See that point? Is that the smallest y, the y value for that is the smallest or the largest? That's the largest. That's the maximum value. That's the maximum point. What about this one?
Minimum.
That's the minimum value. Now, is this the smallest value, y value in the entire graph? Then that's called absolute minimum. Absolute minimum. That's the smallest y value. Is this the biggest y value? Right there? That's an absolute max. While I'm at it, in this neighborhood, the surrounding neighborhood, what is that point? Isn't it still the largest y value? So that's the biggest value of the whole graph. In addition to that, in this neighborhood, that's the largest y value. So in the neighborhood, that's called relative. Relative max. Or sometimes we use local max. Or. So some books use relative, other people use local. In this neighborhood, this point is a relative min. Or a local min. What about in this neighborhood? What is that point? In this neighborhood? What is it? Relative what? Min or max? Has the largest y value, right? That's a relative max. That's an endpoint, but that's also a relative max. In this neighborhood, this is what? That's a relative min. Let's look at that graph. This point here is what? Isn't that absolute max? I don't see anyone with a higher y value than that point. That's the highest one. Nobody above that. Also in this neighborhood, this is what? Relative or local max. Correct. This point here is what?
Absolute min.
Absolute min. Also in this neighborhood, this is what? A local min, right? Do we have any more min or max? Can you see any more? I see two more. Yep, right there, right? The peak value here. That's relative or local. And in this neighborhood, this is what? relative what? Relative min.
What defines the neighborhood?
Close enough. You know, don't go crazy like this big, but just surrounding area, the immediate area. You know. Now, what do you notice about these points, especially the relative ones, in this example, or the maximum here? Well, let's look at them. Let's look at these points here. What is the derivative for them? Derivative is the slope of the tangent line. The tangent line is going to be what? Horizontal? Tangent line's horizontal? Horizontal. And what about the other 2 points? Aren't they the end points? So your extrema value, your min and max, always going to be located either at the end points or where the derivative is 0. You take your derivative, set it equal to 0, find out what the y value is. The one with the smallest y value is your absolute min. The one with your largest y value is your absolute max. So there's 2 places where you're going to find the extrema values, where the derivative is 0 or where the end points. So to find the absolute min-max, check either the endpoints or where the derivative of x equals to 0. That's where they're going to be. Our book, by the way, uses relative instead of local, but either one. They use relative, and I'm sure down they'll use both names. You could also have absolute max and absolute min. That's not the only places for this picture. You could also have it when you have a graph that looks like this. What about if I have a graph that looks like this? Is that an absolute max? And what's the derivative here? Try again. Derivative is what? Undefined, right? Does not exist. So that's really the third possibility. I said either first. What happened to ER here? For these 2 cases, it was where the derivative is 0 or the endpoint. The third possibility, where the function is, you have a derivative, the function is undefined. The derivative does not exist. I mean, the function is defined, but the derivative does not exist. God, my mouth is so dry. So that's where your min-max going to be. So let's give you a problem and see what if we're right or wrong using this information. We have the function f of x equals 3x to the 4th minus 4x squared, and I want to look at it from negative 1 to 2. I want you to tell me where the absolute max is and the absolute min. we said actually where it's going to be either where the end points or where the derivative is 0 or the derivative undefined. This will never be undefined for the derivative. Because to be undefined, that means you must have a fraction, and the value of the fraction on the bottom is what? 0. I don't have that here. So what's the derivative? Three times 4, 12x to the third, minus what? 8x, just 8x, right? Yep. Take the derivative, set it equal to 0. Factor the 4x out. What's left? 3x squared minus 2, right? Set each one equal to 0 and solve it. X will be 0. 3x squared equals 2. X squared equals 0.6667. X will be plus or minus two values. The square root of 0.66667. Plus or minus what? 0.816499. That's good enough. And I'm going to find out which one is the absolute max, which one is the absolute min. And make a table. We're going to test the points. Which points? The end points and where the derivative is 0. I got to make sure these points fit within that. I copied the problem wrong. That's supposed to be cube to make it nice numbers here, whole numbers. But it doesn't really change anything. So I'm going to test the 0, which is between minus 1 and 2. I'm going to test the negative 0.81649. 8165 is good. I'm not going to carry all the digits. Is it still between these numbers? Still a number to use. Positive 0.8165. What else should I test? How about the end points, the minus 1 and the 2? And let's see what the y value for each one of them. Y equals, let me clear this, 3x to the fourth minus 4x squared. When x is 0, what's the y value? 0. When x is negative 0.8165, it's negative 1.333. When x is 0.8165 positive, that's also negative 1.333. When x is negative 1, that's a negative 1. When x is 2, that's what, 32? This is my absolute max. That's the largest y value. And what is the largest y value? We get 2 of them. These 2 are my absolute min. I bet you if we attempt to graph this on the calculator, and I put my window from -1 to 2, let me try that.
What do both x values have, -1 and 2?
Negative what?
These are brackets on top. -1 and 2 are both x values.
Yeah, correct. Oh, right here? Yeah, that's the range, from where to where. So let me set my window. Oh, let me do a second window. Window. I want to go from -1 to 2. And I'll do the y value from -2, because the largest y value is -1.3, to 32. I already type the function, says graph it. That's what the graph looks like. I don't know if you can see it. Notice that's where your absolute minimum. There's one here, and there's one down here. And that's your absolute max right there. So the graph, when you graph it, it looks like this. Close enough. I'm not really going to be perfect here, but it looks like this. So this is your absolute min, right there, the same height, these two. And this is your absolute max. I must have zoomed in more. So that's what the graph looks like. We get two absolute mins, same level, one absolute max. So we always want to take the derivative, set it equal to 0, give these points, test these points and the endpoints. The one with the highest y value is your absolute max. The ones with the lowest y value are absolute min. Let me try another one. I'll give you one where the derivative maybe does not exist. And the interval from -1 to 3. Let's find the derivative while we add it. First thing first, what is the derivative 2x? 2 minus. What is the derivative of this one? 3 times 2/3. Is that 2? X to what power? -1/3. So when you look at that, it says 2 minus 2 over what? The cube root of x. That's really what you have. Now let's take the derivative, set it equal to 0. What value makes the derivative 0? Okay, 2 minus 2 over the cube root of x. Two equals 2 over the cube root of x. The 2 is 2 over 1, cross multiply. The cube root of x is equal to what? 1, right? 2 divided by 2 is 1. What's x will have to be? Isn't it 1? Cube root of what number is 1? Just 1. Is the 1 between -1 and 3? Yes. That's a good number to use. But we're not done. I also need to find out where the derivative is undefined. I always have a hard time when I write this. The derivative equals does not exist. How can it equal something that doesn't exist? You know? So I always, after I write that, I always go, I don't like the equal sign, I always put D and E there. You know? I just don't like the word equal next to it, or the symbol equal there. Losing my voice by the minute. Thank goodness I'm giving a physics test tomorrow. I don't have to talk. So let's take the derivative and find out what value makes that undefined. Well, let's think about it. You want that to be does not exist. The only way you can have an answer to this if what?
0.
If x equals to 0. Why? Because what is the cube root of 0? 0. Can you divide a fraction by 0? Is that point between 0, minus 1 and 3? That's another good point. So now I got to test 4 points. I got to test the 0, the 1, the minus 1, and the 3. Let's make a table here. Oh, I don't know why I went all the way there with it. So let's test these points. I'm going to, this is x, and this is f of x. I'm going to test the minus 1, the 0, the 1, and the 3. I just put them in order. The minus 1 and the 3, these are the endpoints, and the 1 and the 0. Test them into the problem. See which one has the largest y value, which one has the smallest y value. Again, you're looking at this, the function, it's really 2x minus 3 times the cube root of x squared. That's what this one is. That's what 2/3 means. The cube root of x squared. So when x is minus 1, that'll be 2 times the minus 1, which is negative 2. Minus 3 times. What is the cube root of minus 1? Is that negative 1? Square it, that's a 1. So we have what? Negative 5? When x is 0, what's 2 times 0? 0. What is the cube root of 0? 0. Square it. Still 0. So that's a 0. When x is 1, this will be 2 minus 3 times. What is the cube root of 1? 1 squared, that's a 1. That's a negative 1. And the last one, when x is 3, that's 2 times 3, which is 6, minus 3 times. Let's find the cube root of, or what is x to the 2/3? What is 3 to the 2/3? You can write on your calculator 3 to the 2/3. Make sure you put these in parentheses, 2/3. I get 2.08.
The answer is -0.24.
Yep, which is negative 0.24. So looking at them, who has the smallest y value? That's your absolute min. And who has the largest y value? That's where your absolute max is. So the absolute max is 0, comma 0, x is 0, y is 0. The absolute min is -1 and -5. If you graph that function on your calculator, this is what the graph looks like. You'll see they do match. The graph looks like this. That's what it looks like. It's a V shape, right at 0. This is the 0, 0, that's your absolute max. And this is your absolute min. Again, we'll get to that later. That's a relative min. In this neighborhood, that's the minimum value right there. And in this neighborhood, that's what? Relative max. We didn't get to the relative yet. We're just doing absolute. If you have the picture, you get to see it. That's your absolute max, absolute min, the absolute max where the derivative is undefined there. Let's try one more of these. Let's bring in some trig functions. Since you all like them. Can refresh your memory now. Here we go. What is the derivative sine of x? What's the derivative of sine of x? Isn't that cosine x? We have a little problem. This is not x for the cosine, that's the 2x. So you can't use the derivative cosine of x. You have to use the derivative cosine of u. What's the derivative cosine of u? Is negative sine u times what? Times u sub prime. This is my u here. So the derivative of this function, what's my limit from where to where? 0 to 2 pi. So f prime of x is going to be 2 times the derivative sine, which is cosine of x. This is the minus sign. What is the derivative cosine? Negative sign, that will make it a positive sine 2x times the derivative 2x, which is what? 2. So you end up with 2 cosine x plus 2 sine of 2x. And now you want to set it equal to 0. Good luck. Good luck. I say good luck for a couple of reasons. One of them you get cosine, the other one you get sine. That's a problem. The bigger problem, this is x and that's 2x. So So we got two problems. To fix it, I gotta look at the board. And it's number 15 is my solution. You want to make sure these are matching, both cosine and both x's in them. So if I take sine 2x, we have a trig identity that says, wait a minute, isn't sine 2x equals 2 times sine of x cosine of x? If I use that trig identity, I end up with what? 2 cosine x plus, in place of sine 2x, I'm going to put what? 2 sine x cosine x. I was trying to cheat and just skip one step. I'll wait. What's 2 times 2? 4. Now I can factor 2 cosine x out of each one. Set each factor equal to 0 and solve it. Cosine x equals 0, and let's think about it. Cosine of what angle between 0 and 2 pi is 0? If you get the unit circle, that's pi over 2 and 3 pi over 2. Now the second one, 1 plus 2 sine x has to equal to 0. You're multiplying two things and you want your answer to be 0. That means one of them has to be 0. At least one of them. Could be both. I'm looking for that unit circle. I might have it here. Yep. I always leave one handy. Notice we said cosine x equals 0. This is my unit circle. Where's the cosine? Is the first number. 0 at 90 degrees, pi over 2. 0 at 3, pi over 2. Let's look at the sine here. If you solve it for sine of x, you have 2 sine of x equals what? Negative 1. Sine x equals what? Negative 1/2. Where's the sine equals negative 1/2? The sine is the second number. Where's the negative 1/2? I see it here. 11 pi over 6. I also see the 7 pi over 6. See that? So x equals 7 pi over 6 and 11 pi over 6. Boy, are we lucky. We're going to test this, this, and these two values. 6 numbers now. One of them will give me the largest y value. Maybe more than one, but we'll find some of them. And hopefully one will give me the lowest y value. Crooked. So let me take my calculator, get it ready so I can calculate these values. 2 sine of x minus cosine parentheses 2x. So let me test the numbers. The numbers I'm going to be using, we said what? X here and f of x. I'll put them in order. 0 is the smallest one. It looks like what? Pi over 2, the next one. It looks like 7 pi over 6, the next one. Three pi over 2, the next one. 11 pi over 6 the next one, and 2 pi the last one. Again, in case you forgot, f of x equals 2 times sine of x minus cosine 2x. Plug them in. When x is 0, 2 sine of 0 minus cosine 0. And my friend here says, oh, make sure, by the way, you're in radian mode. Ooh. Okay, let's try the 0. It gave me a minus 1. Let me try pi divided by 2. I got a 3. 7 pi divided by 6. I got negative 1.5. 3 pi divided by 2. I got negative 1. That's 11, looks like 4. 11 pi divided by 6. I got a negative 1.5. And the 2 pi, get a minus 1. So where's the largest value? Right there, right? That's your absolute max. And your absolute min, these two. Again, if you have a calculator and you decide to graph it, this is what the graph looks like. 0, negative 1 starts from here, pi over 2 and 3, seven pi over 2, that's what the graph looks like. And this is your absolute max. And these two are your absolute min. They're below that value, just by a hair, by 0.5. Notice the y value is negative 1.5. This is negative 1 here, and this is negative 1.5. And this is the negative 1. And that's the end of that section. The next section is short.